So we have next speaker for the day. That's Suman Devnath. His topic today would be on Docker in production using Amazon Web Services. Suman Devnath is a principal developer advocate at Amazon Web Services. He tries to simplify the intricacy of AWS cloud services to developers, aid them to unravel its optimal possibilities and obtain its utmost usage into their application. Well, his key focus area are into machine learning, data analytics, and storage. He is presently pursuing his MTech in artificial intelligence from Indian Institute of Technology, IIT Jodhpur. Suman has vast experience of working on storage performance measurement, tool development, and also on quality engineering. And he has authorized for 50 white papers on performance benchmarking and monitoring for Hitachi and IBM. With that, I would like to welcome Suman Devnath for the next talk. Thank you.
Thank you so much, Savita. Let me first share my screen. Okay, I guess you're able to see my screen.
Yes, Suman.
Okay,
Yeah.
sure. Thank you so much. Give me a moment. All right. Good morning, everyone. Thanks for joining in, and it's such a pleasure to, participate in such a wonderful event today in the morning. So today, what we are going to talk about is how you can run Docker on AWS. So there are various services that we have as far as the container services are concerned, but we will just look into a few of them, and then we will go over some demo. Okay, so if you look around, you will see that the adoption of container and Docker in particular has grown a lot in last 1 decade or so, and especially in last 4 or 5 years. And it is quite evident that why people are going towards containerization of their application. So if you take an example of Amazon.com. It was a big monolith software which was people were using it for years, and there are different development teams who are working together, but still it was not that easy to manage. But now, over the period of time, it has now been broken into a microservice based architecture, where each and every different features of what you see in Amazon.com are different microservices. Like when you log into Amazon.com or Amazon.in, you see some recommendation coming in your right hand side. You see some reviews for the product that you are searching for. Each and everything is a separate microservice, or the container. It's running at the back in the back end. It is running in a different container. So that is the agility that you get when you deploy your application in the form of container. And companies like Netflix, Amazon, and there's one of the other use case that we have, a company called Turner. So they are one of the leading broadcasting company in the US. They have recently migrated, not that recent, but a couple of years back, they have migrated almost 850 applications to containers, right? And they all are running in Fargate. So we will see what Fargate is, but a container is something that people are really adopting for their production. It's no longer a toy thing which people used to play around at the early stage. So now there are different use cases that you may be aware of. You can build different applications with different programming languages. You can use it for GHCI. You can use for machine learning, scale testing, etc. So most of my career I've spent in the infrastructure side. I worked with mostly storage vendors, and I remember that in the initial days, how difficult it was to test our storage system with different types of hosts like Linux, Windows, etc. And now when I just look back and see that how people do that testing and development of those softwares, it's mind blowing. Like we used to spend a couple of days to set up that system, but now they do it in minutes. So that is from from the infrastructure standpoint. So when you talk about Docker or container, there are different definitions or perspective that you will get depending on whom you are asking or whom you're talking to. Like a developer or web developer will have a point of view of container from the application side. If you ask a software developer who is working in the backend, he might be defining container in the form of virtual machine and how it is different than virtual machine from the infrastructure side. But whatever you define, the point remains the same, that it gives you the agility to do your perform your task it much faster. Now today in the demo, if the demo gods are with me, then we will have an a machine learning model running on the cloud, which is actually wrapped around a Flask Python app, and we will deploy it in AWS Fargate. Okay, we'll see that in a moment. So in AWS, the way that you can consume a container is one is very simple, that we all know. You can have an EC2 machine, that is the virtual machine service that we have at AWS. You can have a EC2 machine and install your Docker engine, and then you create containers. So that is a straightforward thing that you could do for years. But if you talk about the more managed service, we have something called ECS, Elastic Container Service, and it can be used in two different ways. One is on EC2, and one is via AWS Fargate. So the only difference between these two is both are managed, but the thing is, in AWS Fargate, you don't have to manage the backend infrastructure. Like your container will be running in some instance, in some EC2 machine. But when you use a container for using Fargate, those EC2 machines you have no visibility to. So you don't manage those container hosts. So you just deploy your code and run it. Okay, so it's kind of a serverless environment that you get for containers on AWS. Whereas for Amazon EC2, when you use container services on EC2 using ECS, you have to manage the you have the full control of the EC2 instances. So what ECS does is basically it will give you an orchestration layer where you can manage your container in much better way, right? So these are the two broad offerings that we have as far as the containers are concerned. Now to manage this, you have the support for Kubernetes, which is EKS, which we recently started the support, and also we have ECS for Docker containers. And other thing is, as far as the containers are concerned, we play with builds, right? Like, or the images. So these images, which we typically save in Docker Hub, these you can store in Amazon Elastic Container Registry as well. So this is one of the service that we have, where it's just like Docker Hub, but it's in the cloud in AWS. So you can use you can build your image and push it to ECR and then create containers. Okay, so we are going to create one today. Now, before we get into the demo part, I just want to share a few of the insights of how ECS works at a very high level. So ECS is basically, you can think of it as a cluster, right? So it's just a cluster of systems on which your container would run eventually. But when you talk about container or Docker, you have to first define, what container you want, right? Or what is where is that image, exists. So here you define all the details about the container and its image, which port to open, and all of that. So this is what the container definition, defines. So this is just a JSON file. You just have to, update that with the right image and the port number. Now, this is wrapped around by something called task definition. So task definition, you can think of it, as an abstract for the application. So it's kind of a blueprint for your application, where you describe your containers, how it should be run, what are the roles, and what are the resources that it should use, etc. And it's not like one task definition can have only one container, because your application might need a let's say HTTPD container, Apache container, or let's say a Postgres container, and all are working together. So this is where you define from your application standpoint, which are the containers that you should run together to deploy your application. Okay, and one of the important thing that is there in task definition is task role. So as we know, your images, let me use the pointer. Yeah. So in the task definition, you will give some image ID, right, or the container image ID, and that image might be there in the Docker Hub or in the Amazon container registry. And when you deploy the application, someone need to pull those images, in the ECS cluster. And who will do that? So this is where, the task role comes into picture. So in the task role, you define the role that the EC2 system can assume while pulling those images, from Docker registry or Docker Hub or container registry in AWS. Okay, so this is about task definition, and the task definition by itself is not highly available. So if you want to make sure that you need to run a replica of your application in multiple containers, then you have to use and define it in something called service definition. So there you define the number of copies, the HA configuration, and etc. So this is what service definition is about. So these are the three things that you have: service definition, task definition, and container definition. So these are not that complex, but it's just a single JSON file. But there are differences, in terms of what each and every definition does. So I just thought to share some insights about that. And once you are done with this, you can use, again, you can deploy your container either using Fargate or Amazon EC2. Okay, so in our demo, we are going to use Fargate. Okay, so in that case, I don't have to manage the EC2 instance, which AWS will use for my container. All right, so I don't, it will not give me any visibility. Okay, I will have no idea where my container is running. Okay, so the demo that we are going to see now is basically a machine learning model. So if you are from machine learning, or even if you are not, it doesn't matter. But what I have done is I have pulled a data set from Kaggle, where we had details of different types of wine that is available. Okay, and each and every wine has a class label that whether the wine is good, very good, or poor. Okay, and we build a classifier using XGBoost. So XGBoost is one of the algorithm in machine learning for supervised machine learning, and we have built the model using XGBoost, and then we have wrapped around that with a Flask app, so that in the once that app is deployed, you can open the URL and you can give the details about the wine, and it can tell you that whether that wine is of good quality, bad, or whatever. Okay, so this is about the app. So what we are going to do is first we will create a Docker image in our local laptop, and once that is done, we will create a repository using Amazon Elastic Container Registry. We could have used Docker Hub as well, but just thought to use this. And once this registry is ready, we will push that image to the registry, and ultimately, fire up a cluster using AWS Fargate. And then, if it all works fine, you should be able to access that. Okay, so let me come out of this presentation, and let me open the shell. Okay, so now here, so all the code is available in the GitHub. If you're interested, you can play around, or you can ping me later on. I will try to help you if you stuck anywhere. So this is the folder that I am in, Flask app for Docker. And if I want to show you first the Docker file. So it's pretty simple. This is the base image I'm going to use, and I have some requirement. I'll install it using pip. It's written in Python, so it will just install it, and it will just run it through Python. So that is the entry point. And we will be using Flask to deploy this app. Okay, so that's about it. Give me a moment. I just lost the the connectivity. Just give me a moment. Okay, yeah, so now let me come out of this shell. Okay, so now what we are going to do is we are going to run a Docker build command. If you see that now, Docker image ls, we don't have any image. I just pulled that base image so that it takes a little bit of less time, and we are going to build that image in our local laptop. Okay, so it will take a minute or so. So once this image is ready, what we are going to do is we are going to create a repository in the cloud or in the ECR. Okay, so that is what we are going to do, and then we will try to push that image to the repository. Okay, it's pretty straightforward. Okay, so now if you see Docker image ls, we have that image ready, and now what we are going to do is we will try to create a repository. So I'm using AWS CLI, so it's all configured. So you, ideally you need to have the access details like the access key and all that, but it's pretty straightforward. And we create it using ECR create repository command. And once this command is successful, it gives you a repository a URI, okay, or the endpoint. So you need to copy this. And once this is done, what we are going to do is we will tag that image that we have built with the same URI. Okay, so if you see, we are tagging it with the same URI. This is the URI that we got right from the previous command. So now if you see Docker image ls, you see the same image having two tags. Okay, and you can identify this by the Docker ID. It's same. So now that we are done with the repository and we are done with the image, all we need to do is we have to push. So we have, before pushing, we need to authenticate. So we are just logging into the repository, and we can do so by AWS ECR get login password command. And once that is done, we can simply push it. So now what is happening is this image is getting pushed to AWS in the ECR repository. So once this is done, we can go back to our UI console, and we can see the repository and the image inside it. Okay, so just wait for a couple of minutes. So by the time that it continue, let me open the UI and need to go to container services. Okay, I guess okay, so if you come to this, you will find, the, splash screen. And once you create a container, you can see that, here. So now I have one container, one cluster running. So, this is just in case we didn't get time. I thought that to create one beforehand. But if you now come to repository, you should be able to see the repository, what we have created. So this is the repository that we have just created, Flask app Docker 1. If you go to command line, you'll see that, it is completed. Right, and the name of that repository is Flask app Docker 1. Okay, so now that we have the repository, if you go inside this repository, you will find that container image ID. So we can just copy it because we are going to use this while we create that cluster. Okay, so now we are all set to deploy our app. So what we are going to do is we'll go to clusters, and then we can create we can either click on create cluster or get started. So get started will open a wizard only for Fargate, but create cluster is where you will get an option to create the cluster using EC2 or Fargate. So let me show you that. When you click on create cluster, you get three options. Actually, it's a two options. One is using Fargate, another is using EC2, and it's just like they have separate tabs for Linux and Windows. Okay, we are not going to use this. I want to show you something, and that is more intuitive. So we will click on get started, and first thing that you need to define is the container definition. So this is what we have seen in the presentation a moment back. So here you need to define what image you need to run, you need to use for your container, and what is the port. So we will just click on configure, and we can give some name. Let's say Flask container, and we can give the repository ID. So this is the ID of the image which we have just copied, what we got when we pushed that image to our repository. And we want to open port number 80, and we can just click on update. So there are a lot of other information that you can fill in, like amount of virtual CPUs and memories in the advanced tab, but we don't need that. But ideally you will be putting what is the CPU, how much virtual CPU you need, etc., etc. Okay, so I'll just click on update. And the next thing is, now this is updated. So next thing is task definition. So here you need to, so if you look here, if you click on edit, you see that it's a Fargate, and this is the difference that you get when you choose an option for EC2. You will be seeing here EC2, but now that we are deploying it using Fargate, it's saying the compatibility is Fargate. And you can define the task definition. You can give some name, and this is the role that you give. Okay, on the task execution role. So this is the role which the EC2 instances uses in the backend to pull the images and publish the logs, in CloudWatch and all other things. Okay, so this is about the task execution role. And the other thing is here also you can define the task memory and CPU. So here, whatever you define, it's across the whole application. So it might happen that within this task definition, you're running two containers. One container might use more CPU, and the other container might use less CPU. So those all things you can define here. So we are just going to save everything is default. So we are just going to stick with that, and then we will click on next. And here we will define the service details, whether you want replicas or load balancer, etc. So for now we don't need that. It's just a demo app, but you can do so. And then you click on next, and here at last you give a cluster name. So let's say we give Flask cluster. Okay, and once this is done, you can click on next, and you can see that all are green tick. That means all the information AWS is having now to create your cluster. So now you just go ahead and click on cluster. Okay, so it will take a couple of moments, and once we see that the cluster is ready, we can go and see the IP address that we get from the Fargate, and then we can open that IP address in the browser to see that if our application is running or not. Because in the container definition, we mentioned that it should open up port 80. Okay, so one thing, by the time this happens, one thing I want to show you is this. So as Fargate is actually running, Fargate, we don't have the access to the EC2 machine, and we are running here. So this is our own VPC or virtual private network, right? This is my virtual private network, but Fargate is running my container in some shared infrastructure. So here, we have EC2 machines, and this is all AWS. Private network, right? And I'm using Fargate here, right? And when it creates a container, it creates a container on one of these hosts, but this host is not controlled by me, and that's why we call it a serverless, because we don't manage that. But how we access this, the container which is running here, the way that we are able to access is, what Fargate does is it creates something called ENI. Okay, so it creates an elastic network interface, and it comes up with a public IP. And once it's public and you're private the way that you configure. But what this ENI does is it gives you the proxy access to your container, and then you can use this to view from outside. Okay, you can view it from outside. But this is the most important thing that Fargate creates to access your container from where it is hosted by Fargate. Okay, so I just wanted to give you some insights about that. So now that this is done, you can click on View Service, and we can come to Task, and we will see that this is the task definition that we have created. And if you click on this task, you will see that we got an IP address. That this is the public IP address, and this is the IP address of this ENI. Okay, that we have just seen. Okay, and if you before we go over there, if we go to EC2, let me open in a new tab. You will find that there is no a container that is running. All right, so if you see, there is running instance as 0, right? So that this also proves that the container that we have just created using Fargate, it's running somewhere in the cloud, which we don't know. So now what we can do is, since it's in running stage, if we pick this IP and try to open it in the browser, you will see that app. So you can now open this website. I mean, you can browse through this URL, and you would be able to see a model running. So this is hosted on Fargate, a Python Flask app, right? And if you change the wine type, it will tell you what quality of wine it is. So now it's saying that with this configuration, like pH value, alcohol level, density, etc., this is a low quality wine. So I mean, this app is not important. What is important is how you can deploy your model, machine learning model, or in general any application with ease, using Fargate. So that's about it. And if you are interested to play around this, you can open this. You can take this GitHub repo, and you can go over this Flask app Docker, where we have the Docker container, a Docker file, and all the steps are mentioned here, what I have just executed. But if you are into machine learning, and if you want to see that how that model is created, you can get inside ML model, and you will see a Jupyter notebook. Okay, so that's optional, but the important thing is how you can make that app up and running in a container. Okay, so now with that, I'm almost done with the demo, and you can access this IP, and you can play around. So ideally, what happened is now your container, my container is running in the cloud, and it, it can scale, right? Even if you multiple people log in, I don't have to worry. It will scale, based on, the configuration that I have set. Although I have not defined any service level definition, but the idea is, when you define a service level definition where you want, multiple instances of your container, and it should scale based on the workload, you can do so. So you don't have to worry about, what will happen if people, barge into my website or web app one certain day. Okay, so that's all from my side. Feel free to reach out if you have any queries, or if you want to know more about a few of the other services in container space. Like, we did not touch upon how you can run Kubernetes, but we do have a service called EKS. Although I have not worked on EKS that much, but we would love to hear about your use case or how you deploy your app. Okay, so with that, you can scan this. You might get some credits, and again, few of these credit codes doesn't work, but if in case you find any of these credit code which is not working, just ping me or email me. I will send you the right one. It at times it doesn't work. I heard this from many people, but this is the URL. I'll keep it open for maybe 10 seconds more, so that you can scan it. Okay, so
meanwhile, Suman, we have
yeah.
few questions if you can answer them.
Yeah, sure. Yeah.
Yeah, first question, like, what is the advantage of Fargate over EC2 instance?
Sure. Yeah. So one of the thing is, when you look at creating container on EC2, you get a more flexibility in terms of managing your instances, cluster, and all of that. But that also comes with your burden. So if you don't want to manage your infrastructure and you don't want to take the burden of that, then it is recommended that you go with Fargate, right? And if you can manage that, and if you want a little bit of customization as well, then you can go to EC2. Okay, but yeah, if you are a company who is like cloud born, and or we call it as a cloud native, and you just define everything at the application layer. You just write your code to deploy your app, and you have no understanding of, you don't care about the infrastructure, then you should go for Fargate.
Okay, thank you.
Sure. Yeah. All right, so that's about it, and feel free to reach out for anything around container or machine learning in general. Once again, thank you so much for your time. It was a pleasure to be in this conference and talk to you all.